Okay, here we go. Okay, so today's lesson we're looking at metal reactivity, and the key idea about metal reactivity is metals react by losing electrons. So you find metals in groups 1, 2, and 3 on the periodic table. So they have 1 electron in the outer shell, or 2 electrons in the outer shell, or 3 electrons in the outer shell. So a key idea we talked about earlier on is that when an element reacts, it does so to get a complete shell. So the way metals get complete shells is by losing electrons. So the reason they lose electrons is to get complete shells. Okay, so metals react to get complete outer shells, and the way they do that is by losing electrons. Now, last lesson we did an example. We looked at the reaction between magnesium and hydrochloric acid, and we wrote this equation. And what we looked at was the idea that the magnesium has changed. The magnesium was magnesium atoms at the start of the reaction. At the end of the reaction, the magnesium was a magnesium ion. So the magnesium has changed during the reaction. We also looked at the hydrogen. Here we have hydrogen ions in the acid. And on this side we have hydrogen atoms that are actually joined together to form a molecule. So on the left-hand side, we've got our hydrogen ions, and we've got 2 of them. And on the right-hand side, we've got hydrogen atoms that are bonded together to form a molecule. One thing we also spoke about last lesson was that the chloride ion is present on the left-hand side, and it's also present on the right-hand side. So the chloride ion doesn't change. It's just a spectator ion. So it's present in the vessel, it's in the test tube or the beaker, whatever you're using, but it's an ion at the start and it's an ion at the end. So we call that a spectator. So we refer to something that doesn't change as a spectator ion. So let's look at the substances that do react. So the chloride ions stay the same. They're not part of the reaction, but the magnesium changes and the hydrogen changes. Okay, so let's look at that in detail. So the magnesium started off as magnesium atoms with 2 electrons in the outer shell. After the reaction, we had magnesium ions. And the reason we had the magnesium ions is because the electrons have been lost. So we started with magnesium atoms that have 2 electrons in the outer shell, and those electrons were lost. So here's our lost electrons, which leaves us with a magnesium ion. Where do those electrons go? We can't destroy electrons. They have to be transferred to something else. So let's look at the hydrogen now. So the hydrogen, we started off with hydrogen atoms. That actually, not hydrogen atoms, hydrogen ions. And the hydrogen ions have no electrons in the outer shell. So a hydrogen ion is just a proton. That's all it is. So it has no electrons. So what's going on here is that the hydrogen ions gain some electrons. Let's just look at grabbing 1 electron first. Let's just put that in. And then it forms hydrogen gas. So in order to balance this, we've got 2 hydrogens on the right-hand side, but we've only got 1 here. So to balance that, we put a 2 in front of the hydrogen ion, and we'll look at that there. One more thing to check is that the charges are also balanced. So on the left-hand side here, we have 2 times plus 1. So the charge on this side is plus 2, and the charge on this side is 0. The charges have to balance as well. So to make it balance, we need 2 electrons, because the plus 2 minus 2 will equal the 0. So there's our 2 reactions. So the magnesium atoms lose electrons, and those electrons are gained by the hydrogen ions. Now there's words for this. There's a couple of words that are really important to learn. Okay, so up the top there, we have what's called an oxidation reaction. Because electrons have been lost. Down the bottom, the second reaction we refer to as a reduction reaction, because electrons have been gained. Now, it's quite an easy way to remember this. That's the old oil rig. So I'll just write that as an acronym. So the way it works is oxidation is loss. So when a substance loses electrons, we say that the substance has been oxidized. Okay, if a substance gains electrons, we say it has been reduced. So the acronym is oil rig. And so the rig bit is reduction is gain. Okay, so we say that the magnesium has been oxidized, and we say that the hydrogen ions have been reduced. Okay, so the magnesium atoms have lost electrons, so they've been oxidized, and the hydrogen ions have been reduced because they've gained electrons. Let's look at a different scenario. Let's try a different situation. Let's say this time we've got a different reaction. So we've got lithium, let's say, and we're reacting the lithium with hydrochloric acid. Actually, let's do a different acid. Let's do sulfuric acid. And the basis there is we've got a metal plus an acid, make some sort of salt, and the old hydrogen gas. Okay, so in terms of writing our chemicals down, so I've sort of done words and symbols. Let me just go to just symbols. Let's do that. So we've got some sort of salt, so it's going to be lithium something, lithium sulfate, and hydrogen gas. Okay, before I balance, I need to make sure I've got the correct formula. So I'm pretty confident about the lithium, pretty confident about the sulfuric acid. Not so sure about this, but I'm fine with that. Okay, so my lithium sulfate, so lithium's in group 1, so it's got a charge of +1. Sulfate is in group, sorry, not in any group, it's a radical, but it's got a charge of -2. So the 2 comes down, the 1 comes down, so it's Li2SO4. So I just need to add a 2 there. So I've got the correct formula, and now I can go ahead and balance. So I've got 1 lithium atom here, but I've got 2 over here, so I need to put a 2 in front of the lithium. 2 hydrogens here, 2 hydrogens there, 1 sulfate, the rest is balanced. Okay, so let's now write down, maybe it's a good point now to pause it. If you're watching this video yourself at home, pause the video and have a go at writing the reactions yourself, the 2 half equations, the oxidation reaction, and then the reduction reaction. And watch the next video. We'll stop it.